Okay, today's lesson is angles formed by chords or secants. This is lesson 14.3. Yes, we are skipping 14.2. So what we're going to be looking at is how to find the measure of an angle made by two chords if we know the arcs that they intercept. Your homework is not the worksheet. It's problems 3 through 7 on page 841. Okay, so here is what we have. We have three different situations that can happen whenever you have two chords or secants intersecting with a circle. They can intersect inside the circle. So notice here these two chords are intersecting inside the circle. These two secants are intersecting inside the circle. And notice the difference between a chord and a secant is a chord terminates at the circle and a secant is a line, so it continues on and on and on and on. The second situation we might have is they might intersect on the circle. And we've already talked about these as intercepted arcs and intercepted angles. And then the third situation, they might intersect outside the circle. Now with the chords, you don't see the intersection outside the circle, so this would only be with secants. So we would see that a secant intersects outside the circle. It would intersect right out here. So these are the three situations we're going to look at today, and we're going to look at the relationship between the angles and the arcs. Okay, here's our first situation. This is the one where they intersect inside of the circle. The picture I have here is the two secants intersecting. This intercepted arc is 40 degrees. This intercepted arc is 50 degrees. And what I want to find is I want to find the measure of angle DEB. So if I want to find the measurement of angle DEB, and remember because they're vertical angles, AEC is the same measure as DEB. So I'm going to find either this angle or this angle. They're both the same, so it doesn't really matter which one I'm looking at. All we have to do is find the average or the mean of the two intercepted arcs. So in this example, what I would do is I would add this intercepted arc, 40, to this intercepted arc, which is 50. So 40 plus 50 is 90. Then divide them by 2. So that tells me that this angle right in here and this angle over here are both 45-degree angles. And since, of course, I know that those are 45-degree angles, I also know that this one is a 135-degree angle in case that's part of the question. So that's all I have to do to find the measure of either this angle right here or this angle over here. So that's whenever the chords intersect inside of the circle. The next one is whenever they intersect outside the circle. So notice I have this secant and this secant. My two intercepted arcs, I have the big arc, which in this case is 112 degrees. I have the small arc, which is 26 degrees. And I want to find the measure of angle CEA. So where before we found the mean of the two, now what I'm going to do is I'm going to subtract the two intercepted arcs and then divide it by 2. So I'm going to take the 112, subtract the 26, that gives me 86. I divide the 86 by 2, and that gives me that this angle measure out here is 43. So this is the second situation whenever the two of them intercept outside the circle. Now, we've already talked about whenever they intersect on the circle. Whenever they intersect on the circle, it's called an intercepted arc or an intercepted angle. And all we have to do is remember that the angle is half of the arc measure. So if I wanted to find the measure of angle DE, I think that's D. If I wanted to find the measure of angle DEB, I would just take 160 and divide it by 2. So that tells me that my angle measure is 80. So that's the third situation that we might have with the intercepted or intersected secants and chords. So now let's do an example that uses that. So here's a kind of complicated looking example that we want to look at. So the first thing I want to do is I want to look at it and I want to find any arc measures that I can before I even get started. They give me this one as 112. they give me this one right here is 93, and because if you look at this one, if I extend it on out like this, that is an intercepted angle. So that means this arc that's out here, this big arc, is twice 93, so that's 186. So I know that that big arc out there is 186 degrees. So that gives me a couple of things to work with. So now the first thing I want to find is the measure of angle D. Well, if I look at angle D, and I'll highlight angle D in red for you. Here's the measure of angle D. It goes out that way and it goes up this way. Okay, so notice angle D intercepts the entire circle except for this 186 degrees. So what I did over here, I took the 360 and I subtracted the 186 that I wasn't using, and I got 174. To get this one, since it's an intercepted arc, I just take the 174 and I divide it by 2. And that gives me that this angle right here is 87 degrees because I took 174 and I divided it by 2. So that gives me this one as being 87 degrees. Right there. Okay, so that took care of the measure of angle D. Now they want me to find the measure of arc BE. So let's take a look and see where BE is. BE is this arc right here. So right there is arc BE. Now there's a little bit I can figure out trying to do arc BE, and that's one of the reasons I had you go ahead and write the whole arc measure, because this is the only piece of the arc that we don't know. The whole circle is 360 degrees. I already know that this piece is 112. I know that this piece is 186. So I just subtract those two from 360, and it tells me that this arc right here is going to be a 62 degree arc. So that gave me BE. The next one they asked me is for arc CD. Now, if I'm looking at arc CD, and let's use a highlighter for this one so that we can see it. So we're looking for CD. Let's look at the two secants. So I want this arc right in here. Now if you remember, whenever we have two that intersect outside of the circle, what we would do is we would take this one, we would subtract the 62, divide it by 2, and get 43. So I wrote that down as algebra, that 43 equals the one that I'm looking for, subtract 62, and then divide by 2. So then all I do is I manipulate the equation so that I can find out that x is 148. And what I did to get that is I multiplied 43 by 2, and then I added 62 to it. So now I know that this arc right here is 148. So I'm going to clear off a few things here, and I'm going to write in my arc measure, 148. Okay, so I know that one. Okay, so now they're asking me for arc ED. Well, arc ED is a piece of this big 186 degree arc. I know that CD is 148, so all I did was take the 186 and subtract the 48. That gave me 38, so I figured out that the measure of arc ED is 38. Next they want me to find angle C, which is this angle right here, angle C. Alright, so I had just figured out that ED right here is 38. Okay, so I have that measure. So to figure out angle C intercepts two arcs. It intercepts the 62 degree arc and the 38 degree arc. So I'm going to add my 62 and 38 and divide it by 2. That tells me that the measure of angle C is 50. Okay, let's take a few things off here. It's getting a little messy. Okay. Alright, so we found the measure of angle C. The last thing they asked me to find is the measure of angle BED, and I'm going to use the highlighter again so we can see it. BED. Well, I notice that BED intercepts this arc 112 and this arc 48. So I added 112 and 148 and divided it by 2, and that gave me the arc measure, or excuse me, the angle measure of 130, because I added these two, I divided by 2. When I added these, I got 260. 260 divided by 2 is 130. So this is lesson 14.3. In lesson 14.3, we were talking about angles formed by chords and secants. We looked at the 3 different possibilities of where they're going to intersect. Here I would find the mean, or the average, of the 2 arcs. Here I would just divide the arc in half, and here I subtract the arcs and divide by 2. So now what I'd like for you to do is go to page 841, do problems 3 through 7.